a repeated measures ANOVA, also called a within group ANOVA. I'm going to go ahead and run this for you. So let's pull up the data set. There it is. So the big thing about a repeated measures ANOVA is there's only one group, right? Everybody gets measured in all the measurements. So if there's only 2 repeated measures, that would be a paired t-test. But if there's more than 2 repeated measures, that becomes the repeated measures ANOVA or the within group ANOVA. So we got a pre-therapy depression score, a during therapy depression score, and a post-therapy depression score. So if the therapy worked, their depression scores should go down over the repeated measures, but we're going to check them all anyway. All right, first thing we're going to look for is normality is still an assumption for the ANOVA, for this ANOVA. So we're going to check that real quick. We're going to go to descriptives, explore, and I want all 3 of them in there. And unclick the stem and leaf, click the histogram, and we want the normality plots. And there is our output. This is what we're looking at here. So according to the Kolmogorov-Smirnov test, the pre-test did not violate it, but the during did, and the post-test did not. So switching over to the Shapiro-Wilks, they got the same thing. So the middle measurement, the depression during therapy, did violate the assumption of normality. We're not going to worry about that now. We're going to go ahead and run the test. So we're going to go up here to analyze. Let's get this down where you can see it. Analyze general linear model and repeated measures. Shkabam. And we got 3. And I'm just going to call it time as a factor. Doesn't matter what you call it. But then we're going to click and add them. We're going to define them. And it's 1, 2, 3. And over here, we're going to get the options again. We always want the descriptives, the effect size, and the power. Now, with this test, homogeneity variance is not an assumption. The new thing we're going to look at, the new assumption is called sphericity. And I'm going to explain that here in a second, but we're not going to click that. If you can click it, you just get a little error message there. But let's go ahead and hit this bad boy. So here's the 3 repeated measures. Remember, only one group. Everybody got a pre-test, everybody got a during test, and everybody got a post-test. And they're the means. You can see right off the bat, there's a giant difference there. So it's going to be significant. And we could use this, the multivariate test box. We normally use the Wilks Lambda down here, and it is significant. So that means there's a significant difference between the average means. That's all it means. This is the new one that you're looking at. This Mauchly's test will check to see if the data violated sphericity or not. Real quick, here is sphericity. Let me see if I can't pull this guy up here real quick. That is sphericity. So since there's only one group, we want the people, everybody in the group, to change as a group. Okay? So there's the first measurement. They're all around, what is that? I don't know, 0. The second group, they all go down a little bit. Third group, they all go down a little bit again. Again, we want them to go like a school of fish. But there's videos here. Just watch them if you're not clear on that. That's the assumption. So let's keep going. So we look at the sig value of the Mauchly's test. And like always, whenever you're checking an assumption, if the sig value or the p-value is less than 0.05, that means it violated that assumption. The only big deal here is it did not violate it, so we don't have to worry about it. But if it did, if that sig value was less than 0.05, all you would do is pick one of the, either these are called corrections, Greenhouse Geyser, the Hunfeld, or the lower bound. We tend to use the Hunfeld, but that's not the case in this one, so let's keep going. So time, that's our box, right? So we're going to go sphericity assume because it was not violated. So this is all the information from our test. And it was significant, right? You had a F ratio of 17.574, which is big. Your effect size is pretty big, 0.481, and your power is perfect. So there was a significant difference in the repeated measures. Now let's go down and see if the therapy worked. We go back up to the averages here. So their pre-depression scores were high. During therapy, they went way down, way down. But then after therapy, they tended to creep back up, but not as bad as the original. So it looks to me like the therapy did work. Okay, that's it. Hope that helps. MGZ, out.